Section 9.2 is on page 527, talks about arithmetic sequences. So, the definition is kind of odd. I'm going to explain what that means. You just need to understand it. It says, in an arithmetic sequence, the difference t, called the common difference between two consecutive terms, is the same. Let me elaborate what that means. Arithmetic sequence, you take a sub 1, a sub 2, a sub 3, a sub 4, a sub n. If this is a sequence, if the sequence is arithmetic, then this is really how it is. You take a sub 1, and to get the next term, you add d. That's really what that means. If you take, okay, forgive me really quick. So, to get from one term to the next, you add the same number. That's what they mean. So it has to be the same number. So, to go from A1, to get to A2, you take the first term and you add this common difference. To get from this term, so A sub 1 is given, let's say. If you want to find A sub 2, you take A sub 1 and you add D to it. To find A sub 3, the third term on the list, you take the previous term and you add D to it. But A sub 2 is A sub 1 plus D, and I'm talking about right there. And that would be A sub 1 plus 2D. Does that make sense? So the next term up, if you add, isn't that A sub 1 plus another T? Isn't that 2D? How about A sub 4? Isn't that the previous term? And you add a D to it. Isn't that A sub 1 plus 3D? A sub 5, isn't that A sub 1 plus, what do you think? 2, 1D, 3, 2D, 4, 3D, 5, isn't that 4D? If this trend continues, A sub n, do you notice every single one of those contains an A sub 1? Do you notice every single one of those contains some multiple of D? The only varying part, it seems, if this is 2, there's a 1 in front of this. If this is 3, there's a 2 in front of this. If this is a 4, there's a 3 in front of this. If this is 5, there is a 4. So it seems whatever this is 1 less. Whatever this is, it seems you're taking that D and you're multiplying it by 1 less. And that's what this is. To find the general term of an arithmetic sequence, which is the star of a section. Anything you want to do, you're going to aim for A sub n. A sub n will find any term on the list. Or give me any term on the list. Replace it by A sub n. I'll solve for n and tell you where it is on the list. So here they're saying on number 1, assume that A sub 1 is 3. Now this part I'm writing, you don't have to. The common difference is negative 2. So you add a negative 2, that's a 1. You add a negative 2, that's a negative 1. You add a negative 2, that's negative 3. Add a negative 1, that's negative 5. Negative 7, negative 9, negative 11, negative 13. This list goes on. So an arithmetic sequence is a sequence in which, and the reason they call it D for difference, to find D, take any term subtracted from the previous term. Common difference, that's what D stands for. Take any term subtracted from the previous term. That tells you what you're adding every time. Here they're saying, look, A sub 1 is 3, we got it. The common difference is a negative 2, we added negative 2. They want to know what A sub 9 is. One way of doing that is say 1, 2, 3, 4, 5, 6, 7, 8, 9. But what if I ask you for A sub 90, A sub 900? Basically, I'm going to force you to use this formula. I want you to find the general formula. To find any term on this list, it's going to be A sub 1, and I suggest you write that on your homework as many times until you get it. So the first term in this case is a 3, plus n minus 1, and the common difference is a negative 2. And if I clean this up, okay, just kidding. If I clean this up, I'll notice that a sub n is 3 minus 2n plus 2. The general term for this sequence is 5 minus 2n. That's how you find any term at all. And if they say find us a sub 9, a sub 9 is 5 minus 2 times 9, 5 minus 18. That will be a negative 13, which is right there. And if on a test I'll say find a sub 95. Well, no need to, you don't have to list 95 of those. You could say it's right there. That's 5 minus 2 times 95. That is 5 minus, and what is that? Is that 190? If not mistaken. And that is negative 185. I could find a sub 1000, a sub 2000 again. So we don't want to use trial and error. We want to find the general term. The general term by finding d every time. Here it's given. And plug it in the formula and figure out the general term for any sequence if possible. Here is another problem. It says, oh, I forgot the directions. And here it is. It says, find the general term of each arithmetic. They're telling us this is arithmetic. What does that mean? That means to find the general term, that is the very first term plus n minus 1 times the common difference. What do I need for this? I need two things. I need the first term. It's given. Hey, half of the problem's done. The general term is 36 plus n minus 1. What's missing? I need the common difference. And I'm done. How do you find the common difference? Well, let's see. They said a sub 9. So now you're going to really figure out how this plays. They say a sub 9 based on this. Isn't that a sub 1? Plus, isn't it whatever this is 1 less, 8 times d, and what does that equal? That equals a 4. But I know what a sub 1 is. A sub 1 is actually 36. It's given. It's right there. I'm using the highlight. Right? And I could solve for d, and there it is. One equation, one unknown. I know how to solve all of those. Negative 32. D is a negative 4. Once I know what d is, pretty much I'm done. If I take this d and put it right there, I have just figured out the general term. That is 36 minus 4n plus 4. So the general term is 40 minus 4n. That will find any term on the list. And you could check, plug in 9, you'll get 40 minus 36, which is a 4. And what if they didn't give me the first term? Well, that's okay. Why is that? Because I know about systems of equations. So I'm looking at a sub 6. A sub 6 is a sub 1 plus 5 times d. And that equals a 20. Very good. A sub 12. I know what that is. That's a sub 1 plus 11 times d. And that equals an 8. Does that look familiar? This is like saying x plus 5y equal 20 and x plus 11y equal 8. Right? I could use elimination. I could use substitution. I could solve any way I learned. What am I looking for? I'm looking for the very first term and the common difference. I plug those in and I'm done. So, if I look at this system of equations, if I solve the top equation for a1, isn't that 20 minus 5d? Now I'm going to take this and substitute that right there. That would be 20 minus 5d plus 11d equal 8. That would be 20 plus 6d equal 8. 6d equal a negative 12. d is negative 2. And once I figure out what d is, I plug it in and say a sub 1 must be 20 minus 5 times a negative 2, which is 20 plus 10, which is 30. So a sub n would be the first term, which is 30, plus n minus 1 times the common difference. A sub n would be negative 2n. 2 plus 30 is 32. And there it is. Now, I do want to make a note really quick. I could have taken this system of equations. This is something we didn't cover because they skipped the first section. I could multiply the top by a negative 1. That makes this negative a1, negative 5d equal negative 20, and add those, and get 6d to equal negative 12, and therefore d equal a negative 2. And once I find that, I could go to the first or second equation, say a sub 1 plus 5 times negative 2 equal 20. So a sub 1 equal 30. Again, you could use whatever you want, substitution, but you have to show me what you're using. Substitution, elimination. Just do not use graphical approach. That's unwise. Now, history time. Let's talk about history. Back in the days, a teacher walked into a class and asked, the class was loud. He walked in and asked the students to add from 1 to 100. A student sitting in looks down, writes two numbers, and tells the teacher the answer is 5050. Now the teacher, of course, didn't know the answer. So after they work it out, it turns out to be the same. So he said, okay, smart guy, why don't you do from 1 plus 2 plus 3 all the way to 1000? And the student looks down, writes two numbers, and gives him the answer. And then when was asked, how are you getting that? Do you notice this is arithmetic? The student said, if you take the first and the last and add them, isn't that 101? If you take the second to the last, the second and the second to the last, and you add them, isn't that 101? If you add 3 plus 98, isn't that 101? He said, so if you take the first plus the last, and if each two of those add up to 1, so each two of those are giving me the 101. How many of those pairs are there? Since it's 1 to 100, there is 50 of them. And how did he get 50? He said, well, whatever those are, divide them by 2. And that's where the 50, and then he said, I just multiplied 5 times that, and added the 0. Now to do that, since this is arithmetic, they figured out, well, look, if you take a sub 1 plus a sub 2 plus a sub 3 plus a sub n. If you're adding in an arithmetic sequence the first n terms, to take the 1 plus the 100, that's like the first plus the last, times, since you have n of those, each pair will make one of those, so you're going to have half of n. And they came up with this. For that kid's name was Gauss. Very famous kid. He was 8 or 11, I can't remember. So if you're adding, if you're taking S, the sum, I equal 1 to L, or n equal 1 to L of a sub n, that would be the very first term. That will be the very first term plus the very last term, and you multiply them by L divided by 2, assuming you're starting at 1. And we do start at 1 most of the time. So to practice this, and this is only true for an arithmetic sequence, to practice this, we're looking at find the indicated sum. find the sum of the first 11 terms. Now, I'm warning you. On the exam, I'm going to say find the sum of the first 1100 terms. I'm going to make sure that you're not going to add those on a calculator. If I even allow you a calculator. So, what I need a sub n. You always need a sub n. A sub n is a sub 1 plus n minus 1 times the common difference. Now, everything's here. If I know s sub 11 is 11 divided by 2 times a sub 1 plus a sub 11, I could figure out what this is. This is 11 over 2 times a sub 1. A sub 1 is right there. Plus, how am I going to find a sub 11? I'm going to go on the side and say a sub 11 is the first term, which is a 10 plus. Isn't that 10 times? What's the common difference? What are you adding every time? To find the common difference, take any term, subtract it from the previous term. So I always need to find, well, not always, but almost 98% of the time, I need to figure out what the common, I have to use the common term, or the general term, I'm sorry. So this sum will be 11 over 2 times, and if you take negative 10, that will be negative 121 divided by 2. That's what this sum will equal. Just to make sure. Okay, I did mess up. That's not 121. 11 times 10 is 110, or simply, before you even go there, 2 divides this 5 times, and that will be, let me make sure, negative 55. That would be the sum. Okay, how about this problem? Again, the goal here is not for you to list those out. I'm just giving you heads up. It's not for you to sit down and say what you did on the last section, plug in 3. So that's not the idea. The idea is for you to say, you know what? This is going to equal L divided by 2 times a sub 1 plus a sub L. That is L. You're going from 1 to 6, that's 6 terms. A sub 1, plug 1 in. 2 plus 3 is 5. And a sub L, which is a sub 6, in this case, a sub 6 will be 2 plus 3 times 6, that will be 18, that will be 20. And there it is. That's 3 times 25, that is 75. On your test, I'm going to make sure that you're going to use the formula. So make sure you know how to do that. And how do I do that? Well, that's easy. I'll say add the first 605 terms. You want to do it on a calculator? Good luck. And all what you have to do is follow the formula again. Make sure you're doing that. Here's a problem. Let's see if we can do this. One application. Determine the seating capacity of a concert venue with 70 rows of seats. 70 rows of seats. If the number of seats in each row form an arithmetic sequence and there are 50 seats in the first row. So the first row has 50 seats. The second row is a bit wider. It could hold 54 seats. And the third row can hold 58. This is row 1. This is row 2. This is row 3. We have 70 of these rows. So, I'm taking 50 plus 54 plus 58 plus, I'm not sure what the last one is. I'm taking the first plus the second plus the third, but I know this is the 70th. So, can I find the general term? The general term is the first term plus n minus 1 times the common difference. The first term is 50. The common difference, what are you adding every time? Take any term, subtract it from the previous term, you're adding 4. So the general term is 50 plus 4n minus 4, which is 46 plus 4n. What do I need? I need to know what the 70th term is. What's the 70th term? That is 46 plus 4 times 70. That is 46 plus 280. That is 6. That is 12. 326. Now what? They're saying find the capacity. How many people can you fit? That is adding all of those. If I take the sum of those, S sub 70, that is L divided by 2 times A sub 1 plus A sub 70, right? According to the formula. That means the sum of those is 70 divided by 2. The first is 50. The last is 326. That would be 35 times a 6, a 7, 327. So 376 times 35, 35, 38, 15, 18, and 18, 21, 22, 9, 10, 11, 0, 16, 11. That could hold 13,160 people. I'm going to say seats. So this concert hall, arena, whatever it is, can hold 13,160 people. Isn't that cool? How about here? It says, find the missing terms. This is an arithmetic sequence. 2, 9. If it's arithmetic, what did you add to 2 to get 9? You added 7. Add another 7, that's 16. Add another 7. That is 23. Another 7, another 7, another 7, another 7. Whoops, something went wrong. What went wrong? I added 2 plus 7 is 9, 16, 23, 30, 37, 44. You guys, you don't have to add. Plus 7, 51. Plus 7 is 58. There you go. And there's your homework. So the next section up is geometric sequence. What do you multiply to get the next term? That's the same idea.